Viking wall ovens frequently necessitate a dedicated neutral conductor. This is due to the electrical design of these appliances. Traditional wiring for 240 volts appliances typically uses a 10-3 with ground non-metallic sheath cable, or NMB. This cable contains 3 insulated conductors consisting of 2 hot wires and 1 neutral wire, plus 1 bare ground wire. However, Viking wall ovens mandate a 10-4 with ground NMB cable. This cable includes 4 insulated conductors which consist of 2 hot wires, 1 neutral wire, and 1 dedicated neutral wire, along with the standard bare ground wire. The reason for this dedicated neutral lies in the operational characteristics of Viking wall ovens. These ovens generate a substantial return current and therefore need a dedicated neutral conductor to manage this current effectively. Employing a shared neutral wire with other circuits can result in voltage imbalances and various electrical issues. The extra wire in a 10-4 with ground cable usually is white with a black stripe. It is essential to always consult the manufacturer's installation instructions for any appliance you are installing. This ensures that you adhere to the specific wiring requirements and safety guidelines for that particular model. Failure to follow these instructions can lead to improper operation, electrical hazards, and voiding of warranties. When working with electrical wiring, it is important to understand the different types of wires and their applications. The 10-3 with ground NMB cable, as mentioned, is commonly used for 240 volts appliances that do not require a dedicated neutral. The 2 hot wires provide the 240 volts power supply. The neutral wire provides a return path for the current, and the ground wire provides a safety path in case of a fault. In contrast, the 10-4 with ground NMB cable is specifically designed for appliances like Viking wall ovens that need a dedicated neutral. This dedicated neutral provides an additional return path for the current, reducing the load on the shared neutral and minimizing the risk of voltage imbalances. When installing a Viking wall oven, ensure that you use the correct type of cable and that you connect the wires to the appropriate terminals. The 2 hot wires should be connected to the line terminals on the oven, the neutral wire should be connected to the neutral terminal, the dedicated neutral wire should be connected to the dedicated neutral terminal, and the ground wire should be connected to the ground terminal. It is important to tighten the terminal securely to prevent loose connections, which can cause overheating and electrical hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to install the Viking wall oven. An electrician has the knowledge, skills, and experience to perform the installation safely and correctly. They can also ensure that the installation complies with all applicable electrical codes and regulations. Before starting any electrical work, always turn off the power to the circuit at the breaker panel. This will prevent electric shock and other electrical hazards. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. If you are unsure about any aspect of the installation, consult the manufacturer's instructions or seek the advice of a qualified electrician. In general, understanding the purpose of the neutral wire is essential in electrical wiring. The neutral wire is a conductor that carries the return current from the appliance back to the source. In a 120 volts circuit, the neutral wire is typically connected to the grounded neutral point at the service panel. This creates a complete circuit, allowing current to flow from the source to the appliance and back to the source. In a 240 volt circuit, the neutral wire may or may not be connected to the grounded neutral point depending on the specific application. In some cases, the neutral wire is only used to provide a return path for the current, while in other cases, it is also used to provide a 120 volt supply for certain components of the appliance. The ground wire is a safety conductor that provides a path for fault current to flow back to the source. In the event of a fault, such as a short circuit, the ground wire will carry the fault current back to the source, tripping the breaker and energizing the circuit. This helps to prevent electric shock and other electrical hazards. The size of the wires used for electrical wiring is determined by the amount of current that they are expected to carry. The National Electrical Code, or NEC, provides guidelines for wire sizing based on the amperage rating of the circuit. For example, a 30-amp circuit typically requires 10 American wire gauge, or AUG, copper wire. The NEC also specifies the type of insulation that is required for different types of wiring. NMB cable, as mentioned, is commonly used for residential wiring. It consists of insulated conductors enclosed in a non-metallic sheath. The insulation is typically made of polyvinyl chloride, or PVC, which is a durable and heat-resistant material. When working with electrical wiring, it is important to follow all applicable electrical codes and regulations. The NEC is the most widely adopted electrical code in the United States. It provides comprehensive guidelines for the safe installation and maintenance of electrical systems. Local electrical codes may also apply, so it is important to check with your local authorities to ensure that you are in compliance. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical wiring. For example, Underwriters Laboratories all provides testing and certification services for electrical products. UL-listed products have been tested and found to meet certain safety standards. The National Electrical Manufacturers Association, or NEMA, is a trade association that develops standards and guidelines for electrical equipment. When selecting electrical products, it is important to choose products that meet applicable standards and are UL listed. This will help to ensure that the products are safe and reliable. When installing electrical wiring, it is important to use proper wiring techniques. This includes making secure connections, protecting wires from damage, and routing wires in a safe manner. Improper wiring techniques can lead to electrical hazards, such as short circuits, overheating, and electric shock. When making wire connections, use appropriate wire connectors, such as wire nuts or terminal blocks. Ensure that the connectors are properly sized for the wires and that they are tightened securely. Do not over-tighten the connectors, as this can damage the wires. Protect wires from damage by using conduit cable trays or other protective measures. Avoid running wires in areas where they are likely to be exposed to physical damage, such as in attics or crawl spaces. Route wires in a safe manner by avoiding sharp bends, excessive tension, and contact with heat sources. When running wires through walls or ceilings, use appropriate drilling techniques to avoid damaging the structure. In addition to these general guidelines, there are specific requirements for wiring different types of appliances and equipment. For example, appliances that use a lot of power, such as refrigerators and air conditioners, may require dedicated circuits. These circuits should be sized appropriately to handle the load and should be protected by a dedicated breaker. Appliances that are located in damp or wet locations, such as bathrooms and kitchens, may require ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect ground faults and to interrupt the circuit, preventing electric shock. When installing electrical wiring, it is important to have a good understanding of electrical theory. This includes understanding concepts such as voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Power is the rate at which electrical energy is transferred. It is measured in watts. Ohm's law is a fundamental law of electrical theory that relates voltage, current, and resistance. It states that voltage equals current times resistance, or volts equals amps times ohms. This law can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Power can be calculated using the formula power equals voltage times current, or watts equals volts times amps. This formula can be used to calculate the power consumption of an appliance or device. Understanding these basic concepts of electrical theory is essential for working safely and effectively with electrical wiring. In summary, installing a Viking wall oven requires careful attention to the wiring requirements. The use of 10-4 with ground NMB cable is often necessary to provide a dedicated neutral conductor. Always consult the manufacturer's instructions and follow all applicable electrical codes and regulations. If you are not comfortable working with electrical wiring, hire a qualified electrician to perform the installation.